Everyone, welcome to the last lesson where we are going to apply the Yeo Johnson method for the transformation of our three numeric variables. And in this particular method, we are going to see and make conclusion or identify the most appropriate transformation for a particular variable. We at first need to generate the Python code for Yeo Johnson method. So definitely we will use the same command, but for now the command we need for Yeo Johnson transformation method. So run the command. Here you can see the lines of codes, and definitely I think you have identified the similar thing. All the codes are similar, like the codes we have found for boxcox method, except the dot Yeo Johnson is used. Dot Yeo Johnson is a particular method that is also belong to the states package. That is why the state package is imported by ChatGPT, and we have already imported the package, so we do not need it again. So you can see that in the particular line of code, just the change is dot Yeo Johnson, and all other things are similar. We just copy the code, go to Jupyter Notebook and paste it here. Definitely we have to make some changes. So at first we'll write Yeo underscore order val, and within the brackets of Yeo Johnson function, we'll filter out our variable order underscore value underscore euro, and everything is okay. We just need to copy the line of code for kd plot and paste beneath it, and we have to replace the boxcox underscore refund by Yeo underscore order variable, within which we have loaded our transformed order value euro values following the Yeo Johnson transformation. Now run the code. So here you can see the distribution or the transform distribution for order value euro is similar as the distribution of boxcox method for the variable order value euro. So no change. So we can pick either the transformation of Yeo Johnson method or boxcox method for the transformation of order value euro, because both are similar. However, now we will copy the similar line of code to test the transformation for cost variable. So we'll change the order value euro to cost, and the variable within which the transformed cost values will be loaded is Yeo underscore cost. Definitely you have to replace the Yeo underscore order val by Yeo underscore cost, and now you have to run the code. You can see the transformation or transform distribution is similar for the cost variable we have found for the boxcox method, but I think the Yeo Johnson method is more perfect compared to the boxcox method, and you can use one of them, no problem. In my case, I will definitely use the Yeo Johnson transformation method for the cost variables transformation. And finally, we have the variable for refund, and for which we have found no best transformation technique, and definitely we have to change it, but change it to refund, and the variable within which the transformed refund values will be loaded is Yeo underscore refund. We will replace the Yeo cost variable values by the Yeo underscore refund, and now run the code. You can see the distribution is similar as boxcox, so we have found no transformation for the refund variable. So we have to keep the actual variable or actual values for the refund variable, which is much more appropriate compared to the result we have found by using square root transformation, logarithmic transformation, boxcox and Yeo Johnson transformation. So at last we can make decision that for the order values euro, we will use the boxcox transformation methods values. We will use the Yeo Johnson transformation method values for the cost variable, and we will use no transformation for the refund variable. So that's all. In the next part of the course, you are going to use these transformed variables or the actual variables of refund to test several statistical analyses such as one-way ANOVA, correlation test, and regression analysis. That's all for now. Thank you.